So here is our head. It has been glass beaded at 40 psi, and the exhaust thread inserts have been done, and the guides have been removed. So when I remove Norton guides, I use one of two methods. If they're iron guides, I use a stepped bit and bore them out. This head had bronze guides in it. Bronze is a bit tough to bore, and since they have a high expansion rate, they're sensitive to temperature. So then I use this thing, which is probably not even legal anymore, but what it is it's called a cold punch, or that's what we used to call it. It has a fitting on it, and it's hollow, and it has holes down here which are connected to this fitting. And outside I have a tank of propane with a valve on it, and I screw it on this fitting, and after the head is heated to 285 degrees, I slip this down in the valve guide and turn on the propane liquid, which comes out in the middle of the guide and supercools the guide, and that makes it contract enough that it just takes a couple light taps and it comes out. And that avoids scoring up the guide holes any more than they are. And of course, since it does have bronze guides in it, they have been replaced before, so who knows what method was done before, but here is my gauge reading on the guide hole, and it's telling me that if I were to use a standard guide, I would only have a 0.5 thousandths interference, which is really not enough. So I would be installing 2 thousandths oversized guides. Now, to fit the 2 thousandths oversized guides in the head, I used this little straight hone. It's a pin hone, and I will just remove a 1/1000 and a half or so, which will give me or remove about 1/1000, which will give me about 1/1000 press fit on the guide. So this guide has already been honed. And so we're about 1/1000 over, basically a 1/2 inch, which means that the new guide is going to have a little over 1/1000 press fit, which should be just about right. And here is our valve guide installing tool. There's a hydraulic cylinder under the bench, and a little hand pump here that runs it. And the guide fits in this little adapter, which fits on here. And the guides are coated with a Teflon based lubricant, which helps ease them into the cylinder head. And the head is in the oven getting warm, and once it gets up to 375 degrees, I'll show you how I put the guide in. To install the guides. Here's our hot cylinder head. Here's our guide. Screw it down to start with. And there's one installed. There's two installed, and I'm going to go ahead and proceed with the two exhausts, which will be done just the same way. Okay, the guides are installed, the head is cooled off now, and we're going to ream them. So here's a little bit of cutting oil. Here is a carbide reamer, and this reamer is roughly a 1/2 thousandths smaller than the valve stem, so it'll need to be honed after this step. And here we have a guide that locates in the throat of the seat, so that we make sure that the guide stays concentric with the seat. And that's it. So here the head is now ready to hone the guides to size. So we can check our valve guide size here. And actually we are right at valve size, so we're at 0. So for an exhaust guide we need somewhere around 1.8 to 2 thousandths clearance for the average street engine build. So we will see what we can do here. Here's our little sun and guide hone. Has to be used with coolant. Now it says we have 1/2 thousandths or 6/10 of a thousandth of clearance. Got a little farther to go. Here we are at 1.4, 1.5 thousandths. Almost there. There we are, 1.9 thousandths, right where we needed it. Now for the final, take off any little sharp edges and burrs, we will use a little diamond ball hone. And that's all there is to it. Now 3 more to go. Okay, here's our cylinder head ready for the next step. So basically, if you look at the stud holes, you'll see that the thread is partially pulled up, which means basically that it's on its way out. So what we're going to do is install hard bronze inserts for the 3 studs, and we're going to resurface the head. So when we resurface the head, we need a way to mount it. So what I've got is some adapters that fit in here, and these are ground to a precision thickness, and they locate against the squish band in the head. The reason I do this is because many heads have already been cut before, and they're not always cut very straight, so they may not be true to the squish band, so you end up with one squish band thicker than the other. So these locate on the squish band, and now I'm going to turn the head over and bolt it down to my cylinder head mount here. Okay, we have the head mounted to the jig with those machined washers in the combustion chambers seated against the squish band. Now we're going to mill the 3 head steady mounts so we have a reference point that is basically parallel with the squish bands. Okay, here's the next step. As the cylinder head bolt holes tend to close up at the top and get a dent around the washer, we are opening them up and milling a new surface, which will help me locate the head for the next step. So here we have the head bolt holes all true and clean. So here we are, the head is mounted and located, and we're now removing the original threads from the stud holes, and we will be installing some bronze inserts. Here the mill is threading the hole for the new insert. Here we have one hole threaded and ready, one hole with the insert already installed, and one insert ready to install with a bit of JB weld on it. And here the inserts have been surfaced and drilled. Mill is cutting the threads. And here we are cutting the surface. Looks like the first cut of about 4 thousandths is going to be enough to clean it up. Okay, here we are back to the bench mount and ready to cut the valve seats. So someone has been at these seats before with a automotive style cutter and obviously cut a 15-degree cut on the top, which got into the aluminum a little bit around the edge of the seat. But they weren't cut deep enough that by going back with the correct angle of cutter, I was able to establish a good seat height. And you can see here's 3 cuts. The top cut is 36 degrees. The little narrow cut that's highlighted with a black line is the seat, and that's at 45 degrees, and it's roughly 40 thousandths wide. And then the lower cut is a 60-degree throat cut. And basically we'll be doing them all that way. Of course, the exhausts will only have 2 cuts because the inside diameter of a Norton exhaust seat is too large to give you any room for a bottom or throat cut. And here you can see on the valve, after a light lap, that the seat is basically square in the center of the valve. So here you can see the exhaust seat. It's about 60 thousandths wide, and it's all the way to the inside edge of the seat insert. And biased toward the outside edge of the valve, but not quite all the way to the edge, which is just about as good as you can get on a Norton head. So now we're ready for the final step, which is going to be vibramilling and the final cleaning, and we'll run a thread cleaner through all of the threads and and assemble it with a new set of springs. So here's the head in the Vibra-Mill, where it will be peened with porcelain beads. There's no abrasive to it, so it just smooths the surface and cleans it very well. Okay, so here we are installing valves. And for lube on the valve stems, you only want to use motor oil. A good synthetic blend is nice, but you do not want to use grease on a black diamond valve in a aluminum bronze guide, because the clearance is tight and grease or even thick engine assembly lubes may make the valve stick. So we follow the manufacturer's recommendations and just use engine oil. The seals I prefer are these little white all Teflon seals. They stand higher temperature than any of the Viton or rubber seals. These are good for 550 degrees all day long and they never harden. And it takes a special tool to put them on because they are a tight fit. And we'll get that done and then I'll show you the springs. And here are the springs that I like to use. These are a conical wound spring that I get custom for Norton Motors, and a titanium collar that I have custom made, and here is the head in my valve spring tool, basically, which is a old arbor press that has been converted into a giant valve spring compressor. It also has a gauge on it for height and spring pressure. So you can see we have 94 pounds on the seat, and that is installed with no extra shims, just the factory insulating washer. And I'll go ahead and install the rest of the springs and make sure all of them are in the 93 to 95 pound area on the seat, and we'll be good to go.